much harder to get a 7 in chemistry than it is in bio. So the grade boundaries are very low. Okay, I have my data booklet. This is page 39. All right, guys, I'm gonna go ahead and get started in 5 minutes. I hope it's low for physics. Yeah, it's always very low for physics. Physics is horrendous. All right, give me a second. Damn, the paper twos are long. I keep forgetting how long paper twos are. Okay, I can't do the whole paper two with you guys, but maybe I'll ask you which questions you want to do and which questions you want to skip, so I make sure that I'm doing what you guys want to prep for. Okay, let's go ahead and get started. I'm just gonna make sure, will you do SL papers? I'm happy to do SL papers, just more people vote for HL. So if you really want to do SL paper, try to join when the live just starts. I know it's a hard ask because you don't know when it goes live, when I go live, but you can try to join in the beginning, maybe turn our post notifications on for the TikTok live, and then you vote. Can you say which ones are SL questions? Of course I can. So do you think the biology boundary will be low? I think so, yes. All right, I'm going to go ahead and get started. This is the Specimen paper 2025, HL Chemistry paper 2. So if you guys could help me out, if someone new joins and asks, can you please let them know that? And the discount code for the crash course is M2510. For some reason, every single time I try to pin that one up, it doesn't stay pinned, which is unfortunate. That's okay. All right, let's go ahead and get started. So this is 2 hours and 30 minutes. We'll try to do just at max 1 hour because we really have to go. But it says a monoprotic acid HX is found to have the following composition by mass. So 39.99%, 6.73%, and this much percent of oxygen. Determine the empirical formula. This would be a really nice question to get on the exam. If I opened the past paper and saw this, I would be smiling from ear to ear. So I hope you guys feel the same way about empirical formulas. Am I the only one that thinks paper 2 is easier than paper 1? No, I'm there with you. I hated paper 1. I used to score really badly, and the only thing that helped me improve is just doing a bunch of past papers. Is it okay just to do past papers? Yes, if you do so many. Like for me, when I was studying, I did from 2010 to 2022. And so I did lots and lots of past papers. So if you do enough and you expose yourself to enough past papers, yes. But if you're thinking of like, I'm going to do 1 or 2 past papers and then, think that's enough, it's definitely not. All right, so how would you guys do this empirical formula? I'm going to give you a couple of seconds to answer it. Oh, yay, and we already hit 5K likes. Thank you guys so much. Okay, I'm going to make the live goal 20K. Our maximum we got was 30K, but I don't know if you guys are up for doing 30K, but I would really, really appreciate it. And also try to share the live if you can. Thank you for all the presents. This is SL. So if you're SL, you should be able to do this. So how would you do the empirical formula, guys? I haven't seen anyone comment on it. Is it because we're not sure? Is it because you just want me to solve it? Let me know. If you just want me to solve it, I can also just do it. What subjects do you cover on live? So on lives, I generally do, I just do past papers. So I just ask people. Very good job, Alessia. Inez, Isa, good job. So on lives, I just do past papers, but on the crash course, we cover every single topic, which is nice. So if you're really interested in covering the topics one by one, you can join the crash course. So the first step is to assume these are masses. And if we assume they're masses, we can just say that there's 39.99 grams of carbon. And we always know for empirical formula, the step-by-step is to find the moles and divide by the smallest number of moles. So the first thing I'm going to do is find the moles of carbon, which is just 39.99 divided by the molar mass, because I know grams divided by molar mass is going to give me the number of moles. Okay, so this is going to give me 3.33 moles. And then for hydrogen, I'm going to do the same exact thing. 6.73 divided by 1.01 is going to give me 6.66 moles. And then the final thing with oxygen, 53.28 divided by 16 should give me 3.33 moles. Okay, which one is the smallest ratio, the smallest number of moles? Can you guys tell me? Very good, Alessia. You divide by the smallest moles, then you divide the largest values by the small one. Good job. Good job, Isa. But like, do you only do chem? No, I do biochem. I can even do psychology and math. It just depends on demand. The carbon and the oxygen. Very good, guys. So then I divide this by 3.33, divide this by 3.33, divide this by 3.33. And I know my carbon is going to be a 1 ratio. This is going to be a 2 ratio, and this is going to be a 1 ratio. So my final empirical formula of this monoprotic acid is going to be what? It's going to be C, H, and O. And I want to give you guys a little trick. So from up until I think 2023 to 2024, every single time zone, they've always started with an empirical formula question for the chemistry. For bio, it's always a magnification question. So if you're ever wondering about what you should expect when you open this exam, I'm going to assume it's going to be something similar to this because they've just been repeating it over and over again. Okay, next it says 25 centimeter of a solution containing 1.51 grams of this acid is titrated with this much NaOH. The acid solution is exactly neutralized by 22.3 centimeters of NaOH solution. Determine the molar mass of HX. So how would you be able to determine the molar mass? What are you guys thinking for this one? So if they told me I have 1.51 grams of this, and they've told me that I've taken NaOH here, and this NaOH is this much concentration, and you require this much volume to neutralize this acid, and this acid is 25 centimeter cubed, what can you do? If it's a monoprotic acid, we talked about this in today's earlier live, guys. Can you zoom out a bit? Of course I can. We talked about this in today's earlier live. Do you remember what it means that if I have a monoprotic acid? Remember, a monoprotic acid, it means that I just have, it's not letting me switch this. It means that I just have one hydrogen to donate. So a monoprotic acid, good examples of monoprotic acid are HCl, for example. A monoprotic acid means that I have one hydrogen. Very good, Kavya, exactly. You have one hydrogen reacting with one hydroxyl group. So the ratio is always going to be 1 to 1. Whenever they tell you that it's a monoprotic acid, know that the ratio between your basic base and your monoprotic acid is always going to be 1 to 1. Okay. So that means I know my mole ratios are 1 to 1. So what do I just need to do? I need to find the moles of the base and set that equal to the moles of the acid. How do you find the moles of the base, guys? Pretty straightforward. You say, okay, N is equal to CV. So the moles is equal to the concentration, which I have here, times the volume. Now, what do I have to do to the volume, guys, before I go ahead and sub it into this N equals CV? Yay, we're at 10K likes. Thank you guys so much. Please let me know if the zooming in is a bit annoying, because I don't know why. Usually this works as portrait, and I feel like you guys can see better with portrait, but it's letting me. All right, just frozen. So what do you have to do? You have to divide, very good, divide by 1,000 to convert to decimeter cubed. So then I know the number of moles should be roughly around 0.1, oh no. Let's see here. The number of moles should be 0.0167 moles. And because it's a monoprotic acid, someone was making fun of my likes. So a monoprotic acid, we know that the ratio is going to be 1 to 1. So I've said that my acid is going to have this much moles. And if my acid has this much moles and this much grams, they told me in the question it's 1.51 grams, how can I find the molar mass, guys? What is that equation? I can do physics live. I took physics in uni level, so I can do that. Very good, Aisha. Mass over moles. Good job. So I know this equation that says the moles is equal to grams divided by the molar mass. So if I'm trying to find the molar mass, what can I do? I can just rearrange the equation. Grams divided by moles. So my grams is 1.51 grams. My moles is going to be 0.0167. So my molar mass final outcome is going to be 90.4. Does this make sense, everyone? Please let me know. I'm going to reinsert the discount code for the crash course if you guys want to join. This keeps going away. All right. We hit 12K likes. Yay. Yeah, of course I can zoom out. Yes, it makes sense. What am I drinking? I'm drinking iced tea, but it's like Italian iced tea. How do you know what values? This is an SL question. If you're SL, you should be able to solve this. How do you know what values you should use? What do you mean? I'm from Egypt. Do you consider ESS a science? I do. I'm not really understanding what questions. How do you know what values we should use, but I'm going to move on. You can ask it again, and I'll be happy to answer it. It says, state the molecular formula of HX. So if my molar mass is 90.4, my empirical formula is, what was the empirical formula? It was CHO. How do I find the molecular formula? Oh yay, Hanya is also from Egypt. That's so nice. Do you go to Polytechnic? No, I do not. Someone said, like, how do we know which ones from the sentence we should use? Like, there's so much of it. Ooh, so I understand your question. I think the best way to do that would be literally to write all the values on the side from the question. Like, say NaOH, write the concentration, write the volume of NaOH. Like, kind of draw it out like I did here. And then write the grams of the acid. Write everything down on the side, and then you'll be able to connect those equations to answer this. Do you do bio as well? We do. We also do have bio crash courses. So, I thought the empirical formula, oh yeah, you're right. Sorry, I copied that wrong. So, like this. So how would we find, yes, thank you, Alessia, I miswrote the empirical. But how would we find the molecular formula? Does anyone know? Ooh, guys, this is a very common IB question. Very good, Isa. You find the molar mass of the empirical. Perfect. How do I do that? Well, I know the empirical is 12 plus 2 plus 16. How? Because I have 1 carbon, 2 hydrogens, and 1 oxygen. So that means the molar mass of the empirical formula should be roughly 12 plus 2 plus 16 to be 30. And then to find out how many times my molar mass fits into my empirical formula, I do 90.4 divided by 30, and that gives me a ratio of 3. So you know I have to multiply my empirical formula by 3. So it becomes C3H6O3. And that's my final molecular formula. Does this make sense, everyone? Do you have a live schedule? I don't. It really depends on my availability. Exactly. Very good, Hanya. So you divide the molar mass over the mass of the empirical, then you multiply by whatever the result is. Perfect. Yay. Okay. This is the specimen paper. The Electrochemistry paper 2 specimen paper. Okay, let's do this question. It says HX reacts with aqueous sodium hydroxide according to this equation. Identify the functional group in HX. So what is that functional group in HX? Can anyone tell me? If it's C3, H6, and O3. Very good, Yusuf. Yusuf put the right answer. And how did you know it was carboxyl, Yusuf? Can you tell me? Oh, yay! Someone just bought the crash course. That's so exciting. I'll see you tomorrow. You can draw it out. Exactly. Good job, Alyssa. You can draw it out. And you know it's an acid. So are carbonyls acids? No. We know if anything has a hydroxyl group, it's an acid. And we also know anything that has a carboxyl group is an acid. So we can draw it out and try to find a solution. So if I have 3 oxygens, you kind of have to implement those 3 oxygens in your answer. So you know it's going to be double bond O, OH. And what can you also do? Actually, you don't even have to worry about that. Just because you know that there's more than 2 oxygens, you can already say that if this has to be an acid and it has 2 oxygens, it must have a carboxyl group. Okay? That would be our functional group because that's the only functional group besides the OH, but you would have just 1 OH. That would show that it's an acid. Okay? I'm too broke from the crash course. Oh no. Okay, I'll put in a discount code. It keeps going away, but I'll put in the discount code for you guys who need it for the crash course. One thing we usually do at the end of crash courses, like 5 days before exams, is we like half the price of the crash course in case someone wants to really, really cram. I don't even know if it's 5 days, but like maybe 3 days before the crash course, but before the exams, we half the price because you only get 3 days to study for your exams. And you can purchase it then, but I guess you don't get like the luxury of using the resources for a long time. So if you're really, really adamant in getting it, in buying the crash course, but you're too broke, you could also approach it that way. Okay, next it says the infrared spectrum of HX is shown. And then it says identify the functional groups responsible for the absorption bands shown at Y and Z using section 20 of the data booklet. So I'm going to pull up section 20 of the data booklet because I only have the old data booklet. So IB chemistry, new data booklet. And it's actually really nice, these types of questions, because all you have to do is find the value in your data booklet and then my dog is barking. Apologies, guys. Find the dips, the absorptions in your data booklet, and then find the specific functional group. It's really, really nice. So we're going to go ahead and do that together. I'm just going to open up page 20. Okay. According to your data booklet, in the infrared spectrum, when you have absorptions at roughly 35,000 like this, it's going to be, let's have a look. It's going to be between, it's going to be an alcohol with phenols, and I just looked at that by looking at the data booklet. So it's going to be a hydroxyl group like this, and then for this one, you just have to look at a value between 2,000 and 1,500. If this is not making sense, I can show you guys the data booklet as well, because I know it's harder just to imagine it, or maybe have the data booklet open. That's going to be a, let's see here, a carbonyl. Yes, please, can you show me? Of course I can. So it's just going to be a C double bond O. Let me see. Let me send this to my email so I can show you guys. Is this an SL question? 1 second. I'm going to show you guys the data booklet. Can you show me? Of course I can. Any tips for paper 1B? Ooh, don't use any outside knowledge to answer your question. Especially for bio, I feel like they're gonna really pull something like that on the exam, where they're gonna make something like you would think is common sense in the natural world, but then the data is not gonna allude to that, and it's gonna allude to the opposite. And because you think it's what you would expect, you're gonna get the question wrong. Okay, I found the data booklet. I'm just gonna go to section 20. So remember how I said okay. So remember how I said, sorry guys, this is the opposite way around, but remember how we had an absorption at 3,200 and 3,600 here, in this section here. So that's going to correspond with a OH, an alcohol group, okay? Now we also had another dip at roughly this section here, 1,750. So we know it has to be a C double bond O. Does that make sense how I got that, guys? Let me know. Okay, good. So someone said it's the COO group. Perfect. All right, so you just look at the data book. It's pretty straightforward. And we hit 12K. Yes, you get it. Okay, good. So next you have to draw the formula that is consistent with the evidence. So you have an OH group and you have a C double bond O, something that's going to be part of the carboxyl group. Okay. So I know that my molecular formula is C3H6O3. I know that I have a hydroxyl group, and I know that it has to be correspondent to a carboxyl group, just like someone said in the comments perfectly. So I'm going to draw out my 3 carbons like this. I'm going to draw out my carboxyl group, just like so. And therefore I know that there also has to be an OH group. And it doesn't really matter if you draw on the 2nd carbon or the 3rd carbon. You don't need to know that for now. So you know that your acid has to be something like this. Yay, someone said propanoic acid. Perfect. Do you think this paper is considered hard or easy? Well, I haven't really done it fully, but so far it's been easy. I think usually the organic chemistry questions are a bit harder than this. How do you know there's a carboxyl group? Very good question. So a dip in this section here corresponds to the carboxyl group. We also know that the functional group we've identified earlier had to be a carboxyl group. Okay, but it's more likely because of the dip happening in the Z region of the IR, infrared spectrum. What subject is this? This is IB chemistry, and it's a paper 2. Thank you for all the presents, guys, and the likes. Okay, I'm going to go ahead and move on to the next question. It says, scientific models are used to explain the structure of matter. An alpha particle is a helium nucleus. In an experiment, alpha particles are accelerated towards a thin sheet of gold, and the resulting paths are detected, giving evidence for the positive charge of the nucleus. Okay, angle of detection increase from 0 to 180. Here, the number of alpha particles detected at different angles of deflection are shown. So this is the number of alpha particles here, and it's showing you the different angles of deflection. Explain why some alpha particles follow path 2, rebounding from the gold sheet. So why do some of them follow this second path and rebound from the gold sheet? So rather than going like this, they rebound and go backwards, like here. I'm going to give you guys a couple of seconds. Someone said, bro, my teacher didn't even teach this. Real. I would really recommend that you join the crash course. We teach the whole syllabus, every single thing in the syllabus, every single syllabus point. Because basically the EZ7 founder who created these crash courses, she had a really bad chemistry and biology teacher, so she had to learn all of this by herself. Someone mentioned the nucleus. Very good, Amata. Is this better? Sorry, Yusuf, I zoomed in. Deflects because of the positive. Exactly. It's repelled because it gets close contact, so repels because it gets in close contact with the gold nucleus. And that's all you have to say to get the mark. What specimen is this? This is the 2025. How long will you be on live for? For about 30 more minutes. So they do have to go. Okay, hopefully that made sense, guys. That's why the alpha positive one is deflects. It's not attracted to the positive nucleus, and that's why it goes and repels, because we know that positive charges are not attracted to each other. Okay, next it says most of the alpha particles follow path 1 and pass through straight through undeflected. So just a conclusion that can be made about the structure of the atom based on this evidence. So if some of it just goes straight, yay, Amata got it. And Luciana, good job, guys. If something goes straight through the atom, we can say that most of it is empty space. I really like these types of questions because there's no other way for them to ask it, so every single answer will be the same. Most of it is empty space, and that's why it goes straight through. Perfect, guys. All right, I'm going to move on to the next one. It says helium was identified by analyzing spectra of solar radiation. Outline the appearance of the emission spectrum of helium. So emission spectrum, careful, it's different from the absorption spectrum. You have to be specific. So how would you describe, girl, I don't know, same. This one's easy because every single time they ask you about the emission spectrum or to describe the emission spectrum, it's going to be the same. So just think of how very good, Nicole. Is this physics? No, this is IB chemistry. I feel like I'm missing a lot in the comments, but if someone's asking a question, I haven't seen it, please ask it again. Okay, good. So someone said discrete lines. Good. So these discrete lines that symbolize what? What do these discrete lines symbolize? Discrete color lines, colors of black. Okay, good. This is chemistry. Very good, Nicole. Discrete lines that symbolize. Someone said, energy levels. So they symbolize different wavelengths, and then later on, they're going to connect and symbolize energy levels. But for now, the emission spectrum, these lines correspond directly to wavelengths. Okay, so be careful to make that distinction. When you're defining emission spectrum and absorption spectrum, you're connecting it straight to wavelengths. Later on, we're going to connect these wavelengths to energy levels, which is what we're going to do now. Someone asked previously if this was a hard past paper. No, I don't think so far it's been hard. Okay, next it says, I thought this was physics. I don't even take Chem. That's hilarious. All right. This is emission spectrum of one electron system can be explained using a model with the electron attracted to the nucleus by electrostatic force. This model predicts that the electron occupies discrete energy levels. Some energy levels for H, so the helium ion, are shown. Explain how the frequencies observed in the emission spectrum support the idea of the electron occupying discrete energy levels. And for this, you have to say 2 marks. Oh, that sounded like 2, okay. So someone said lines converge. Okay. You basically, in this point, you have to connect the idea that wavelength corresponds with discrete energy level. So how do we make those connections? Relate to different frequencies. Okay. So what is the point of the wavelength? That they release color, right? So connect how color is released. What is that thing that's being released that shows distinct energy levels? Because remember, we have the visible spectrum, the IR, the UV spectrum, the infrared spectrum. Very good, Isa. Photons, exactly. So we're just connecting how we're going to go from wavelength to energy levels. And the way we do that is by connecting the photons. So energy is released, or energy is released in the form of a photon. A photon is released. Exactly. Electrons absorb a wavelength from photon to get excited and fall back. Very good. Exactly. That's a very perfect way to say it. Are specimen papers harder or easier than actual exam? They're definitely easier. Okay. So we know that energy of a photon corresponds with different wavelengths, or you can say frequencies. Just like someone said in the comments. Okay, and the energy of a photon depends on the energy level. Okay, so depending on the energy level, the more or less strength there is in my energy level, and if it's stronger, I'm going to release different colors of photons in comparison to if it's weaker. So the point here is, how am I connecting the colors and the wavelengths I'm seeing to energy? It's because you have photons that each correspond to different wavelengths, and we know each of those specific wavelengths corresponds to different energy levels. And so we're going to connect it, I'm assuming, in the next question, or you can even explain it a bit more here, that the photon corresponds with different energy levels. How do we connect the energy levels to the photons? Through this idea of wavelengths. Okay? Yay, we hit 13K. Okay, good. I'm happy it makes sense. Next, it says to deduce the ionization energy of helium-ion from the energy levels shown. So what is the ionization energy from this graph? This will be uploaded on YouTube, right? Yes, it will be. It might be a bit late just because I'm having a bit of technical issues with uploading on YouTube. But I will try to upload as soon as I can. See you tomorrow. Can't wait for your memes again. Yay! I'll see you tomorrow, Alessia. Bye-bye. This is biochemistry. This is chemistry. Girl, since you know psychology, any resources? I don't really recommend any resources for psychology because the psychology is very different depending on the teacher who teaches it. Someone says 5250. Exactly, good. Because I know the ionization energy is going from the closest energy level to the nucleus, so n equals 1, all the way up to infinity. That's how I know the ionization energy. So it's going to be basically the amount of this energy, which we know is to be 525. It's not negative because I'm not going downwards, I'm absorbing. So it's going to be 5250. So if you said that, very good job. You don't have to say the units, but I'm just being extra. Okay, I don't know why I keep zooming in so much. It says, suggest 2 reasons why the ionization energy of the hydrogen atom is significantly smaller than the ionization energy of the helium ion. So why is the ionization energy of hydrogen, which has 1 proton and electron, smaller than that of helium, which has 2 electrons and 2 protons? So what can we say? The difference between hydrogen and helium. Hey, Katrina. Hi. What about physics? I can teach physics. It depends on demand. Smaller nuclear charge. Okay, good. So because helium has more protons, that's one reason. Helium has more protons. it's harder to remove electrons because the protons, or the higher nuclear charge, attracts the electrons more towards the center, and therefore it requires a higher ionization energy. Now, what are the two things you have to mention? Whenever the IB tells you, talk about ionization energy, talk about the all those periodicity things. So radius, ionization energy, electron affinity, reactivity, all of those things. What are the two things you have to mention? Nuclear charge is one of them, and we've mentioned them. Very good, MGs. Exactly. Good. So you either talk about the atomic radius or you talk about the radius. Sorry, atomic radius, or you talk about the nuclear charging, the shielding. Exactly. Very good. So we've talked already about the nuclear charge. And then which one would have a larger radius? This is IB. Helium would have the larger radius, right? Because it has one electron and one proton. But we know helium has 2 protons and 2 electrons. So our outer shell electron is full. It's fully satisfied. So the ionic radius for helium is much smaller. Exactly, good. So we can say that the helium plus ion has smaller radius. Therefore, it's harder to remove an electron, or requires more energy to remove electron. Okay, and that's all you have to say. So we've mentioned one of the marks is to always mention the nuclear charge. The other mark is always to mention the radius. Is this HL? This is an HL past paper, but we know that this is an SL question. So if you're SL, you should be able to solve this as well. Someone said, can you also refer to the valence shell from noble gases? Ooh, don't. You will not get the mark if you refer to that. You only get the mark if you mention the shielding effect, or the radius, and the nuclear charge. So be very careful of that. Okay. That's always what's going to be on the mark scheme whenever you get to the periodicity questions. So double check with yourself. Do I need to talk about the nuclear charge? Do I need to talk about the radius? Do I need to talk about both? And that's how you make sure you get the full marks. Okay. I really like, do you mention both or just one? Good question. So here, because it says suggest 2, you know you have to mention both. But generally, what they'll give you is that they'll give you a question where the nuclear charge stays the same, and then they're going to ask you what's causing the difference here. And then you know, because one of them stays the same, you have to talk about the other one. So generally, I would say 90% of questions, you only talk about one, because the other one is always going to be constant. But in this case, because they said suggest 2, you have to name both of them. Okay? Okay, good. Suggest why the model outlined in BII can predict the emission spectrum of He+, but not the He. So why can we only predict the ion, but not the actual helium molecule? Why is this only the helium ion? Someone said that's so weird. I don't remember anything from periodicity. If you want, you can join our crash course. Actually, tomorrow we're going to be covering stoic moles. We're going to be covering the basics of like metallic ionic bonds. We're also going to be covering periodicity. So if you want to join the crash course to review all those SL topics, you can. Can you tell me the time of the crash course? So the crash course starts at 9:30 BST. Here's the schedule of the crash course, so you know what topics we're covering tomorrow. So if you really want to join, make sure you join before tomorrow to get it live. If you just want to purchase the recordings later on, you can as well. It depends on preference. Because if you purchase the recordings, you just can watch everything on 2 times speed, which is nice because everything goes much faster. But if you, of course, purchase the recordings, you don't get the assistant tutor chat, you don't get a chat, and like you don't get to ask the tutors as many questions as you want. Okay? How much is it with a discount? Because I've already got a tutor. So it depends if you're HL or SL. But the discount gives you 10% off. Maybe you can go to the checkout page and then put the discount. Like depending on your HL or SL, it's going to show you. Is it on Zoom? It is on Zoom. Your HL? Okay, and Isa, would you want both the SL and HL content, or just the just the HL content? Because some students prefer to just learn the HL content and don't want to review everything. Yes, both contents. Okay, so both contents would be 205. And so that's before the discount times 0.9. It would be around 185. So the people can talk as well. These are on Zoom. Okay, so the students can't talk. The tutors can talk, but the students can message in the chat to talk. If you think about it, tutoring sessions usually cost between like 60 an hour to 80 an hour, and you're just learning like one topic per tutoring session, but here you get to learn everything. So yes, of course, sorry. I moved on from the past paper. Of course I can. So why is it that I can only look at the helium ion, not the helium atom? Did anyone remember why that's the case? Thank you guys for 13K likes. Okay, someone mentioned noble gases, but what is it? Why is it important that we have an ion? Because we have to consider what when we're talking about these emission spectrums. Not the noble gases, but when we're talking about these emission spectrum, they only work because you're taking into account the interactions between electrons. The movement of electrons, like removing an electron. That's why it's He+. It's positive because we're removing the electron. So only when we're seeing the movement of electrons are we able to actually use this emission spectrum. If there was no electrons moving, if it was not an ion, it would be very hard. Okay? So you need to state that interaction of electrons or movement of electrons is what's needed for this emission spectrum. Okay? Moving on, it says outline why models of the atom have evolved over time. So why has a model of an atom evolved over time? Please let me know. Good, better technology, new discovery, exactly, more knowledge, new technology. I think a really nice one to say is new technology because with reference to anything, technology always evolves. So you can always just write new technology whenever you're better equipment. Exactly, technology improved. Good job, guys. Okay, let's do this one. This is the diagram represents, the development of lithium-ion battery won the 2019 Chemistry Nobel Prize. The diagram represents a cell such a battery delivering a current. Complete the half equations on the diagram and identify the species moving between the electrodes. So, for a lithium-ion battery, is that going to be, what is that going to be, guys? Is it going to be, what's going to be the anode and what's going to be the cathode? What are the charges? Yay, 21K likes. Thanks for keeping me updated. Mine says 13K, I don't know why. Okay. I've zoomed out. Sorry about that, guys. I'm having an issue with my vertical. Good. Would lithium be the anode because it's very active? Good. Exactly. So we know that's going to form in our anode. I mean, it kind of tells us here, lithium in our anode. Anode is negative. Good job. Anode is negative, and my cathode is positive. Okay, so what's undergoing on my anode? What's happening? Is it oxidation or reduction? Someone said I don't get redox. Same. It's very confusing. Oxidation. Good. So I know the reaction that's happening in my anode is an oxidation of lithium. And so basically what I'm going is I'm increasing the oxidation number of lithium. I'm going from lithium solid, which they told me in the question, to form the lithium ion. Plus my oxidation number is increasing. And I know my electrons have to be on the right-hand side because I'm removing that electron. I'm not adding it as if I would do if I reduced. I'm removing it, okay? Now, what is the species moving in between the anode and the cathode? It's going to be my lithium ion. Okay, that's what happens in a lithium ion battery. This lithium ion moves in between my anode to my cathode. Exactly, very good. If you said lithium, you got it right. How do you calculate the oxidation number? So the oxidation number depends on which compounds you're looking at. There's, of course, irregularities, but because this is an element, it has no charge, just an atom, it has no charge. It has an oxidation number of 0. But do you see how this one is +1? This is the oxidation number of lithium-ion, +1. So you go from 0 to +1, so that's how you know your oxidation number is increasing. Okay, now what's happening here? If I start off with my anode, the reason I did anode is for you guys to see it better. But I'm starting from lithium solid in my anode. It's becoming an ion, and I know this lithium ion is moving from my anode to cathode, so you can kind of guess that what am I going to be using in my cathode? I'm going to be using this exact lithium ion, but I'm going to do the exact opposite. So rather than undergoing oxidation, I'm going to undergo reduction, because it is a redox reaction. So if I'm undergoing reduction, what am I doing? I'm taking this lithium ion and I'm adding an electron to it, because we know in redox you're adding electrons. Sorry, in reduction you're adding electrons, and you're forming this final one, lithium COO2. And that's how we go from the anode to the cathode. I always like starting with these questions at the anode because it's much easier to see the flow of the ion. I first in the anode form the ion through oxidation. It moves to my cathode, and then at the cathode, how can you tell it's redox? With voltaic cells, with lithium battery ions, with electrolysis, it's always redox. And in my cathode, it's always reduction, and in my anode, it's always oxidation, no matter what I'm looking at. Okay? Nice. The discharge of lithium-ion battery is spontaneous chemical reaction producing a potential difference and an increase in temperature. Deduce the signs of the following. So if the temperature is increasing, guys, is my delta H positive or negative? I'm really trying to make this vertical, so every single time I zoom in, it doesn't. Very good. Exactly. If you said negative, you got it correctly. Because you know delta H is going to be, it's an exothermic reaction, energy is going to be released, so you know, temperature is going to increase, so you know that it's going to be negative. What about the E cell potential? Someone said positive. Why is the E cell potential positive? Is this spontaneous or non-spontaneous? Positive, good. Why is it positive? Because we know this is a spontaneous reaction. It's telling us it's a spontaneous chemical reaction, and therefore I know it has to be positive. Okay? Which past papers? This is the specimen paper 2025. Is this an HL question? No, if you're SL, you should be able to solve this as well. It is an HL question, but if you're SL, you should solve this. Good. And then what is the delta G? Delta G, if it's spontaneous, it has to be what? Negative, exactly. Very good. So I think this is a really good question to get. And this kind of shows you how specimen papers are much easier than the actual exam paper, I believe, because this was actually a really good question to get. It says the lithium-ion battery can be recharged by reversing the reactions at each electrode. Compare the absolute value of delta G recharge and discharge. So your recharge is going to be larger or smaller. What is it? Your recharge, if I flip the equation, is it going to still be spontaneous? It will be larger. Very good. So tell me why it's larger. Because I know in one reaction, whenever I have a one-direction reaction, it's different when I have two-direction reactions. When I have two-direction reactions, it's always the case that one is spontaneous and the other one's non-spontaneous. Exactly. And we know that for spontaneous reactions, our delta G is always negative. So if I'm flipping the reaction, I'm making the reaction non-spontaneous, and therefore my delta G becomes positive. So I can say in my answer, the delta G recharge is greater than the delta G discharge, because I'm going from a spontaneous reaction, which is negative, to a non-spontaneous, which is positive delta G. One direction mentioned, exactly. Hopefully that made sense, guys. I'm going to move on to this question. Okay, and I think I'm going to end it on this question, so hopefully you have a chance to finish all of 3, because I do have to go. But I really hope this live was helpful. So let's have a read of this one together. And for next time, I'm definitely going to try to fix this zooming in thing because it's a bit annoying. But it says, in a simulation, maybe if I go like this. Okay, in a simulation, equal masses of potassium and lithium are added to water at the time taken for metals to fully react. It's recorded. 5 different increasing masses of each of the metals are used, and the reaction is timed. Sketch the graph on the axis to show the expected results of this experiment. So the time for the metal to react. Oh, I would also love this question. This is a really good question to show up. I could say this is a really easy one. And this is the mass of potassium. So when are you going to be live next? Good question. So it's probably going to be Tuesday, because Saturday, Sunday, and Monday we have the crash courses where we're going to finish the whole SL syllabus, and then I'll only be free again on Tuesday to go live and do a past paper. Okay, so suggest a reason why comparing the time. Oh no, first we have to sketch the graphs on the axis. So how would you sketch these graphs? When you add more mass, what are you essentially adding? More of your element. And if you're adding more, we can think of it as concentration. If I'm increasing the amount, increasing the concentration, what happens to the time for the metal to react? Does it increase or decrease? If I'm adding a higher concentration, adding more mass, increases the rate. Very good job, guys. So if it increases the rate, I know that these both have to be some sort of straight lines. Now, before I finish off and leave it like this, which one's going to have a faster reaction? Is it potassium or lithium? Which one's more reactive according to our periodic table? Someone said potassium. Why is it potassium? Someone said lithium. Why is it lithium? We know our alkali metals, do they increase down a group or up a group? So let's have a look at our data booklet. Here's my periodic table. And I see that lithium is higher than potassium. So potassium is going to react much more aggressively. It's going to have a stronger reaction. So the time for it to go to completion is going to be much faster. Okay, so this is going to have a much steeper line, you would say, because it reaches that time to completion much faster in comparison to this one, which is going to have a less steeper line. So both of them have to be straight lines, and you have to show that as you're increasing the mass, of course, the time increases. But what you also have to do is that you have to show that potassium has a faster rate of reaction. It gets to the time much faster. Okay, so it has to have a steep, like a more, what's it called? This is called steep. This is like less steep line. Okay, that's how we got this one. Suggest a reason why comparing the time for complete reaction of equal masses is not valid for the measure of reactivity. Why is that not an equal measure? Usually, what would we say? Would we say an increase in concentration increases the rate of reaction? And we can't say that grams is directly equal to concentration, right? Because having more mass does not generally equal higher concentration. We assume that, but it's not the most accurate. That's what they're asking. Why is that not valid? Well, because we don't take into account the moles. Take into account moles. Remember, moles is just the amount of, it's a unit of measurement. It's the amount. It's a measure of something. So if we don't do concentration, which is mole per volume, we can't really make that clear connection with grams. So that's how you would get this mark, just by saying we don't take into account the moles. Can you buy the HL crash course later than today and still get to be on the live? Good question. So we go on the live. It's going to start tomorrow at 9:30. So if you mean later today, just before tomorrow 9:30 BST, and you can still join the live. I mean, you can also buy it on the second day and then just start from topic 3. But if you want to join from topic 1, the live, then you must buy it before tomorrow 9:30 BST. You can even buy it in the middle of the day and you still get added to the Zoom call. So it just depends. I would suggest you join as fast as you can, just so you are like exactly before 9:30 BST, so you get to see the whole crash course. Okay, it says lithium carbide is one of the many compounds of lithium and carbon. Determine the percentage covalent character and the bonding type of this compound using section 9 and 17 of the data booklet. So how am I going to be able to see the covalent character of something? Wait, what did it say? Section 9 and 17. Okay. So, can anyone tell me, very good, the difference in electronegativity values? So section 9, what does section 9 tell us? Section 9 tells us the electronegativity values. And what was it of? It was the lithium and carbon. Okay. The lithium electronegativity values is going to be 1. And the carbon electronegativity is, of course, going to have more higher electronegativity because it's towards the right side of the periodic table. It's 3.4. So getting the difference of that would be what? Would be how would you find the change in electronegativity? Wait, so I can buy one day 2 and join and still pay for the whole day 2 and have access to the video? Yes, when you buy the crash course, you get access to all the videos of all the days and you can get all the resources for all the days. But if you mean that if you just want to buy a day pass for day 2 because you want to just do the day 2 units, you can also just buy a day pass with you just get day 2. And you get access to the resources only including day 2. I did IB French and IB English. Okay, so the difference in electronegativity is just going to be the difference between those two, right? So carbon is, oh, I wrote carbon wrong. It's 2.6, not 3.4. Sorry, guys. So the difference in electronegativity would be 1 minus 2.6. So the difference in electronegativity is 1.6. Okay, and does that mean it's ionic or is it covalent? How can we find the ionic or covalent character? We know if it's between what range it's ionic, and what about covalent? Someone let me know in the comments. What are you guys thinking? Thank you guys for 14K likes. I'm gonna go ahead and insert M2510, the discount code if you're thinking about buying the crash course before tomorrow. So you can get 10% off. Please do use the discount code. We offer the cheapest crash courses out there. And we always tell our students, if our customers, if you find a cheaper crash course than ours, because usually crash courses cost between 600 to like 500 to 600, and ours, the most expensive package is 200. And usually the cheapest one is 600 to 500. But our cheapest one is 200. So we always try to prioritize, make our crash courses accessible to everyone. And we tell the students, if you could find a cheaper one, let us know, and we'll decrease our prices. Girl, how are you at 14K? It says 25K on one. Really? I don't know what's going on, guys. I think my technology is not working today. Okay, so how do we find the ionic character or the covalent character? We know one of them is 2. Oh no, I forgot. Let's have a look. 2.6. So one of them is roughly around here. Okay, and then the other one, oh, I can't draw on this. This is annoying. One of them is roughly around 2.6 on the y-axis I'm pointing at. Sorry, guys. And then the other one is at 1. Okay, so how can we see the electronegativity difference? You have to divide that by 2. Good. That's for the average electronegativity. Nice. And you can find that it actually has, what's the percentage of covalent character? It starts at 9:30 a.m. BST. So what are we thinking? How do we find the covalent character? It's going to be between what and what? So the electronegativity difference we know is going to be roughly 1.6. So all you have to do is look at your 1.6 and look at your average electronegativity. Your average electronegativity is going to be 2.6 plus 1 divided by 2 plus 1 divided by 2. That's going to give you 1.8. And your electronegativity difference is 1.6. Okay? So I go to my 1.6, which is going to be roughly, sorry guys, I can't draw, but look at your 1.6 on the y-axis here. I'm going to zoom in a lot here. This is where I'm looking at. And then look at your 1.6 here because that's your electronegativity difference. And then your average electronegativity, remember we said that's 1.8. So it's going to be roughly around somewhere here. I'm going to zoom in here a lot, okay? So it's going to be in a union here. So I know my final one has to be ionic, and the character is going to be roughly around, someone said 51%. Good job. The character can be around 50%. The IB gives you a really, really good range. So if you say anything between 45 and 55, you still get the mark. But I would say I see it mostly as 50. So I say the percentage covalent character is 50%. And I know that it's an ionic compound because I was able to use this diagram. I was able to find the electronegativity difference between carbon and lithium, which was 1.6. So I knew it was somewhere around here on the y-axis. And then I knew that the average was 1.8 because it's, where did you get 1.8? Good question. So I got 1.8 from, you mean the average? I added the electronegativity of carbon, which is 2.6. And then I added the electronegativity of lithium, which is 1. And then I divided that by 2. So it just tells you how to do it here in this equation. And then I got 1.8. So I got 1.8 by looking here at 1.8. And then I found the intersection between 1.8 and 1.6. And that gave me an ionic compound. Did this make sense, everyone? It does? Okay, good. All right. I'm going to end the live today, and maybe on Tuesday we're going to continue with the specimen paper. But I think so far the first 3 questions were really, really easy. Is this in the data booklet? It is. So all you have to do is look at the data booklet. So far